Welcome back to this video. So if you are new to this channel, kindly consider to subscribe, like, comment, so that you can be able to get more videos like this. So this video is actually part 3. So I have part 1, part 2. Part 1 we talked about the missing completely at random, where missingness is completely random and testable. So you can watch that first video so that you can be able to understand what we did. Then the second part 2, we moved to missing at random, where we learned that missingness depends on observed variables. So like in our case, the data that we are using, the observed variables were the age and the education. So that's why multiple mutations assumes missing at random. Now, in this part 3, we are going to talk about, actually, we are tackling the hardest case, which is missing not at random. It's the hardest scenario, but bear with me, it will be a bit lengthy, it will be long, due to there are some things that I need to clarify out. So, but just stick to it and watch until the end. Good. So in my journey as a data analyst and a statistician for the last 6 years, I've handled a number of data, good number of data I can say, and I've handled publications, and I have realized there's a big challenge when it comes to missing data. So you find maybe as a client, maybe you are working on a certain research and you have missing data, then it becomes a problem. So that's why I'm making this video, because now in this video, what I'm trying to uh, bring out is how do you identify whether your data is missing at random, completely at random, and not at random, and how do you make a decision and what assumptions do you make. So this videos helps you to make such kind of decisions. But one thing you need to understand, in these 3 scenarios, only one scenario is testable statistically. That is missing completely at random. That one is statistically testable. So coming to this scenario, missing not at random, it's not actually statistically testable, simply because the missingness of this scenario depends on unobserved values. So it's values that we don't see. So you can't test something that you cannot see. So by definition, I can just say by the definition, we can say that missing not at random refers to a situation where the probability that a data value is missing is systematically related to an observed value itself, or to other unmeasured factors that are not captured in the dataset. So that is so we cannot see, like we can't see those factors. They are not captured in the data. So it is depends on the unobserved value itself. So in practical terms, this means that the reason data are missing is tied to information the researcher does not have access to. Because the missingness mechanism involves unobserved data, it cannot be explained or corrected using observed variables alone. Missing not at random represents the most challenging missing data scenario. Unlike missing complete at random or missing at random, missing not at random cannot be resolved simply by using more advanced statistical software or by adding additional predictors in the imputation model. So you get it right. So we cannot test this missing at random scenario, but we can just as I said on missing at random scenario, we can use some design, maybe some theory. So we can use them maybe to make decision on this missing not at random scenario. You get it right. Good. So missing not at random, we have just said that missingness depends on unobserved values. Number 2, missingness cannot be explained by observed data. So this can only be done under missing at random. 3, no statistical tests can identify missing not at random, and this is what makes it more like makes the hardest scenario. Good. So now in practice, so in this data that we're going to use, so there's a variable by the name health scores. So by just the design and the theory, we can just say that the assume that the health score is actually missing at is just missing not at random what features. So we are going to use so health score missing selectively. So individuals with poorer health less likely to respond. So what do I mean by this? So if I let me browse this. So this is the data, and this is the health score variable I'm talking about. So we have in this data. So what I mean, so if you can see this missing, you can see this missing values under this health what health score. Actually, they are not tied to n of the observed variables. And I said earlier, observed variables in missing data are those variables that do not have any missing data. They are complete. And like in our case, we have the age and the education level. You understand? So this health score actually is not tied to any of this, including even the job satisfaction and the income. So it's not tied to that. So this scenario now, this since this we can assume or we can say that individuals with raw health scores are systematically underrepresented in the observed, like in the observed data. You understand? So while the health individuals are more likely to report their health status. Understand? So like now those that have reported their health score, we assume that they are the health individuals. Now this creates a scenario or a situation where the missingness depends directly on the unobserved health score. So this now the variables that we are going to use to understand that the aspect. Good. So the observed variables cannot explain the pattern. That's what I've just demonstrated. And this missingness depends on true health what health value. So the unobserved value itself. So it does not depend on unobserved what variables. So why missing not at random breaks the standard imputation? Number one, we know multiple imputation assumes missing at random scenario. And I explained this earlier in part 2, so you can get all the information. Then under missing not at random, imputed values may be biased. Exactly. So this is why now this missing not at random breaks the standard imputation. Then increasing imputations does not solve missing not at random. So if you increase the imputation even to 100, even to 80, 50, 40, 30, it does not solve that. Problem is this the missing not at random is just a conceptual actually, not computational. That's why I said we cannot statistically test this scenario. It's just a conceptual what scenario. Then what should you do if you encounter this kind of scenario? So number one, you acknowledge the limitations. So just acknowledge that maybe your data was missing. Maybe after you conceptually you identify that, you just acknowledge the limitation. Then number two, conduct sensitivity analysis. And number three, be transparent in reporting. So if you have, for instance, let us say the same data, we have the what the observed variables. So then our we can apply based since we can justify that the MAR multiple missing at random can work. Since we have observed data, we can justify that theoretically. Then the multiple mutation becomes your primary approach, since we have observed variables. Then but you can conduct what we call sensitivity analysis. You understand? Under this missing notes at random. Good. Now the sensitivity analysis. So we have the sensitivity analysis. What missing note at random means for our results. So missing note at random cannot be tested directly. I'll just say that. Then sensitivity analysis evaluates robustness. Yeah, it's not just a final thing. Results remain stable under missing not at random assumptions, then conclusion are defensible despite uncertainty. So that's the sensitivity analysis. So and then now, based on this demonstration, that's exactly what I want us to do. So I want us now to do the sensitivity analysis, and we see how we can maybe how we can compare these two, the missing at random and what and missing not at random scenario. So just be with me now. So here we are. So the first thing we need to do, based on this, based on this, the the missing not at random scenario. So the first thing we need to do is this. We need to do the normal or the standard multiple imputation based on MAR assumption. After we do that, then we go direct to the what? The sensitive what? Sensitive analysis. Exactly. So allow me to just quickly. So I have to now to start step one. We just declare we declare MI dataset, the data structure. Okay, data structure like that. So we just say MI set, yes, the MLO, just like that. So we said it. Good. Then the next stage, we register now the variables. So we have those variables that are complete or observed variables, and those that are missing. So we register variables at this stage. And what I'm going to do is to MI register. So those that are complete, we register them as regular age. So I have the variable age. So I can actually, to save time, I just click age. This is complete. Then we have the education level. I have these two. So I can cut this, paste it here like that. Then those that are missing, so I have to impute them. So same thing, MI register. So those that are missing, we adjust them as imputed, not regular now. So and in this scenario, we have the income, we have the job satisfaction, and we have the health score. Just that. And cut this and I paste it here. And highlight this and execute. So successfully we have registered the variables. Now next, I love to do what we call the baseline imputation. So let me call it as baseline imputation. So I have to impute the data. Then just say MI impute change. Okay, can just say regress income. Then also just say regress this job satisfaction. I can just copy it like that. Then regress. So all those that are missing, so we are imputing them. Then lastly we have the healthcare. Like that. Then is equals to, now those that are complete, the regular, all this will equal to age and the education level. Then I include the imputation. So let me put 20. Seed can just be any, can just say even 20, 26, you can put any. Yeah, that is it. So let me run. I think it will just take short time because it's not big data, it's just 120 observations. So it's imputing. Perfect. So we have imputed, you can see complete, incomplete. So now imputed 24. So we have imputed all the missing data. Now let me run the baseline now model. Baseline what? The baseline model, since I have imputed the data. So for now, since I have imputed the data, so for you to utilize the imputed data now, we use MI. So like we need to have that command, MI estimate, then just a normal regression, then have let us say here we have job satisfaction, the income, then the health score, the age, and education level. Do that, copy, and just paste it here like that. So now this is the model, the baseline model based on the what? The complete data, and you can be able to see the coefficients like the income. You can see the coefficient, standard error, b values, and so on. So this one is based on what? On imputed multiple imputation estimates. So based on the imputed data. So now what do we do? The next thing is see, now we have done with the what? The multiple imputation, the normal multiple imputation. So let us move to what we call the the sensitivity analysis. So to try to prove now this, not prove, to do the robustness test based on this missing node at random. Now, actually, this sensitivity analysis, what it does, it just modifies the assumptions, but not the original what imputed data. That's one thing that you need to understand. So let us just do the sensitivity analysis. Sensitivity analysis. So already I have the data is set as MWrong, which is good, and I have health score was adjusted as imputed, which is a good thing, and I've done the imputation. So I have to register now what we call a passive variable. So we have what we call register passive variable. So this actually okay, the passive variable, I'm just suggesting that it's actually like Stata, okay, does not allow us to maybe directly change the imputed variable because it will break the logic of multiple imputation. So instead, it has given us that opportunity to create just a variable that represents alternative, missing not at random what assumptions. So it's like now I'm creating from the health score variable. I'm just creating a new the same variable, but now we call it now the passive. That's what we are going to use in our what in our sensitive analysis. So the first thing, I recreate the step one. I recreate adjusted variable. Let me call it like that. Adjusted variable. So I just say generate healthy. I can't say generate healthy underscore. Yes, I get the score m and like that. So this is equivalent to the equivalent to healthy. So actually this is equivalent to the now the variable we have in our data like that. So let me first of all create this health score M and R. So I've just created that, you can see. Then after that's now the step 2, I will now digest again. So says 2 register the as passive. I have to register the variable as what? As passive. Yeah. So I just the same procedure, my register passive, then this health score MNAR, like that. Good. So we have registered that. So I can do that and execute. Health score. Sorry, I forgot H here. Now it must work. Good. So I've registered that there. Then now the next step is actually to apply the missing node at random sensitivity adjustment. So apply sensitivity adjustment. So what I mean by this is that now the health score variable, I can make it worse for those patients who didn't maybe uh, provide their health score. Like I can shift it backward, different -5, -2, -10, any value, like to make it worse. So like we are trying to create a scenario here whereby the variable is really worse. Then we try to run the model and compare the model with the standard or the baseline model above, and we see if there's a difference like in the support of this missing node at random scenario. So that's what I'm actually trying to do. So what I'll do is I'll just say now missing mi passive. So we have already registered that, and you can see I'm not using the estimate. So I replace now I replace this variable that I've already generated is equals to the original variable, which is the health score, like that. Then it has to be like -5. For instance, let me use -5. So um if now this missing I'm supposed to use this cut. If C will start missing, mi miss is equals to 1. Just that. So what I've actually done is that for this observation where health score was like originally missing, I shift the imputed values downwards by 5 units. That's why I've just put -5. So to reflect the was unobserved health like scenario. So I can put even -2, -10. So but in this case I'm just using -5. Like I write that and execute. So you can see for this 20 around 21, everything has been changed. So you can see 45 really changed. So it means we have done that -what? -5. So after this now I can run the like the sensitivity analysis model. So now I'll just say MI estimate regress. Okay. Now I'll put this variable job satisfaction, the income, then this health score, MNAR, age, then education level. Yeah, these are the variable now that I need. So you can realize based on the baseline model here, we use the health score, the original, but this one now we have used a modified one with shift that we have shifted 5 units downward. So I'll just highlight and execute. Good. So we now I have the output. We have the output for the sensitivity analysis. Now it means I have two models. So we have model one. Uh, I've run two models. So model one is under missing at random, now using the standard imputed health score. And the second model under missing not at random, I'm using the shifted health score. You see, and now if you can compare, so you can see the so what you need to look at, just look at the coefficients. Like if you look at the health score, it's negative 0.052481, still a negative. If you go to the original model, so is a negative 0.00199965. Understand? You see, for the like the income is almost the same. So you can see the age, the education level, the coefficients. So they have like changed a bit, a little bit. So now how do you interpret? So based on these two tables, number one, authoritatively I can say that this data, like you don't confuse, like this data or this kind of analysis does not mean that the data supports missing at random. Number two, it does not mean that the data supports missing nodes at random. Yes, but what the conclusion we get from here is that the conclusion is just we have a robust we have a robust that is appropriate to pressable missing note at random violation. Understand? So like that's a kind of conclusion we are we like we are going we are getting from this scenario. Like even if the missing healthcare score was systematically worse, the result would not change. Okay, that's what we mean. Like we get from this. That's why you see I shifted the health score to worst scenario, like downward, like 5 units, -5. So, but still, you can see there's no big change actually, because if you look at this the original model, it was negative 0 point to 3 decimal places is negative 0.001 002. If you do that, this one is negative 0.005. So it's not accurate. It's no the results would not change that what that much. So what when we use, so what we in this scenario, what conclusion or decision would you make? So as a data professional expert, what I can say based on this analysis, number one, I reuse the missing at random based multiple imputation as the main analysis, because it is identifiable and it is standard. It's simply because we have observed variables, the age and the education level, which are complete. So I can use that as my main model. Then I reuse now the missing node at random only as a sensitivity analysis to check just the what the robustness, just that, the robustness. Yes, so now the for your analysis, you can use that. You do the main model, and based on the MAR, the multiple imputation based on the missing at random, and you do what you call the sensitivity analysis. So that's exactly what I wanted you to understand, and I think I've managed it, and I've shown you how to do the normal multiple imputation and how to do the sensitivity analysis under a missing note at random scenario, which I've already done, and you have seen the output for the two analyses. So that's it. So if you have any question, maybe any concern, you can reach me out directly. Just check on my description. There's my email. There's a link to my website. You can also go there. You can be able to see actually what I've explained here. If you didn't get it well, like maybe, and if you want it more detailed, so there's a documentation for that. There's this, you will be able to get this Stata do file. You'll be able to get the missing node at random, an overview, so explaining everything. and an example based on this health score, so you can be able to get all those information. Yeah. So and if you need any help, maybe with your data, you are working on a research, maybe you have difficulty with handling missing data, maybe you need help with the statistical analysis, maybe some consultations, I'm available. Just reach me out and I'll be able to help you out. So thank you for watching. See you next time.